Welcome to Ask and Learn.
Let's use the ratio test to determine whether the series converges. So let's look at this term here, an. That's 2n factorial divided by n factorial squared. Now the ratio test suggests that we look at the limit n goes to infinity, absolute value an plus 1 over an. Let me go back there, we got a little sloppy. A n plus 1 over an. Now we can drop the absolute value here because an is positive. So the numerator, let me do this in red. This is 2n plus 2. So notice that if you increase n to n plus 1, this is 2n plus 2. And then we have factorial, and then n plus 1 factorial, and that's squared, divided by an. Now let's go ahead and simplify this a little bit. So this term up here, this 2n plus 2 factorial, I can write that as 2n factorial 2n factorial times 2n plus 1 times 2n plus 2. That's this term right here. And then I could also bring this n factorial squared up into the numerator. And then I'm left over with, here I see this 2n factorial, and then I have n plus 1 factorial. So let me write that as n factorial times n plus 1, and then that's squared. So this is corresponding to this term over here. Corresponds to this term. And of course here I should write the limit out in the front somewhere. Limit as n goes to infinity. Let me bring this down to the bottom left. So here we should cancel out as much as we can. We see that we can take off those 2n factorials. Here we have n factorial squared. That'll cancel off with this n factorial that's being squared. And then if we look around, we see that in the numerator, we still have 2n plus 1, 2n plus 2. In the denominator, you have n plus 1 squared. This limit is equal to 4. Just look at the leading terms of these quadratics. This is bigger than 1, so we can conclude that the series from 1 to infinity, 2n factorial over n factorial squared, diverges by the ratio test. And that's our final answer.